Hello everyone, today we're going to do package services in a 1 version 7.9.1.3. Package server identify MAC and IP addresses. Objectives. Part 1, gather PDU information for local network communication. Part 2, gather PDU information for remote network communication. What is a local network communication, remote network communication? Look at this topology. Here's the router. We know that the function of the router is to interconnect the different networks. And here there are two LAN interfaces or default gateway interfaces on the router. And each interface is connected to a different network. One is 10 network. One is 172 network. Okay, the local network communication is the communication between two devices that are in the same network. Like here, the communication between the computer 172.16.31.5 and computer 172.16.31.2 is local network communication because these two computers are in the same network. Remote network communication is the communication between two devices that are located in two different networks. Like here, the communication between computer 172.16.31.5 and a laptop 10.10.10.2 is remote network communication because these two devices are located in two different networks. Background. This activity is optimized for viewing PDUs. The devices are already configured. You will gather PDU information in simulation mode. Here is the simulation mode. We are currently on the real-time mode. But later on, we're going to switch to the simulation mode to collect the information and answer a series of questions about the data you collect. Instructions. Part 1, gather PDU information for local network communication. Review the reflection questions in part 3. In part 3, we're at part 1. So you need to take a look at the reflection questions in part 3 before proceeding with part 1. It will give you an idea of the type of information you will need to gather PDU information as the packet travels from 172.16.31.5 is this computer to 172.16.31.2 is this computer. So the communication between these two computers is a local network communication. So we're going to collect the information. So let's go to this computer 31.5, go to desktop, command prompt. From 31.5, we ping 31.2. We ping 172.16.31.2. Okay, the ping should be successful because all the devices have been configured already. So ping is successful. Let's switch to simulation mode here. At ping again, I use up arrow and enter. We generate a PDU. This envelope icon represents PDU, but ignore the color. The envelope color, no matter, ignore it. On my computer, the envelope color is green. On your computer, probably is different. But just look at the envelope. So let's click. We enter this PDU. You said it's OSI model, outbound PDU layer. Here's our OSI model. OSI stands for Open System Interconnection, and out layer, or the outbound PDU layer. The 3-layer information displayed here. So let's look at here what information they need us to collect. Here's a destination MAC, source MAC, source IP, destination IP, at device. So these 5 items. So look at device is 31.5, which is the source device as well. MAC address. Layer 2 is MAC address. There's a double greater than sign. On the left side of the sign is a source MAC. On the right side is a destination MAC. Here, layer 3 is IP. information, the source IP, destination IP. So we copy this information to put them into this spreadsheet. That's what they want us to do. But here is the example. We just go through the information and we have additional PDU information to collect. All right, so capture forward to move the PDU to the next device until PDU reaches its destination. Record PDU information you gathered into the spreadsheet here. Okay, so add device 31.5, 31.5, there's a destination MAC, source IP, destination IP. Okay, all are here. So capture forward, the PDU moves to switch 1. Let's click the PDU on switch 1. So here we see only 2 layers information displayed here. That's because the switch 1, switch is a layer 2 switch. Switch only works on layer 2. Use the MAC address to transmit information. So no IP address displayed here. IP address is layer 3 IP address. So copy paste here, switch 1, MAC address, and no IP address. But we can find the IP address from outbound PDU details. Let's click this tab. So under the IP header, there's a source IP, destination IP. We can find IP from here. All right, so keep going. Capture forward, PDU moves to hub. Let's click the hub PDU. So here, only one layer 1 information displayed here. That's because hub only works on layer 1. So no MAC and IP address information displayed here. But it's still same way we go to the outbound PDU can find the MAC and IP information. So here's the address, destination address. This address is a MAC address because this address is under the Ethernet 2. Ethernet 2 is on layer 2. Layer 2 use MAC address. So here's a destination MAC, source MAC, and source IP, destination IP. So, but under the OSI model, no. So hub doesn't have this information. But we find the MAC and IP address from outbound PDU detail, this tab, not from the OSI model. All right. Capture forward, keep going. And we notice hub spread out the information received from switch 1 to these 2 interface. That's because the hub only works on layer 1. After hub receive message, hub will not check the MAC and the IP address information for the message. Hub just spread out the received message to all other ports, even if the received message is unicast. So that is the function of hub. Hub just pass message. Hub will not determine which port is connected to the correct device, which port is not. It just led to the devices to make decision, led to the correct device to receive the message, and the incorrect device to reject message. That is hub. Okay, let's click this PDU on the destination device 31.2. Because all the MAC address and IP address information are here. So this 31.2 computer works on layer 1 through layer 7. But this message is PIN. PIN use ICMP protocol, and PIN works on layer 3. So the highest OSI model layer is layer 3. So we copy this MAC and IP address information to here. 31.2 is a destination device. So let's do some analysis to this information. We find out on the destination device, the destination MAC and the source MAC switched or reversed, and the source IP and destination IP reversed. That's because After the destination device receives the ping from source device, it will process it and create an echo reply and send it back to the source. This outlayer information is for the echo reply, sending back to the source device. So the echo reply will travel back in the opposite direction. So these reversed addresses are for the opposite journal of echo reply. Another information we get from here is the source MAC and the source IP belong to the same source device. Okay, source device is 31.5. Let's hover the cursor to the computer 31.5. Look at the IP address in the middle, 31.5. That is IP address. All the way to the right, the MAC address, the first one, C788. That is the source MAC address. Belong to the same source device. Okay. And destination MAC and destination IP belong to the same destination device. Let's go here. So look at the middle, IP address 31.2 destination device. On the right, MAC address 1DA7, that is a destination MAC. So, and also from source to the destination, just one hop from source to the destination. Just remember this. Next is step 2, gather additional PDU information from other pins. So there are 2 pins we need to do. One is pin 31.2 from 31.3. So between 31.3 and 31.2. The second one is pin 31.4 from 31.5. Let's go to do the first. Let's go back to the real time. From 31.3, pin 31.2. Let's go to command prompt. Pin 172.16.31.2. Okay, pin is successful. And we switch to the simulation mode. And pin again, I use up arrow. Okay, we generate a PDU. This time the envelope color become orange, brown. So click here. With add device 31.3, all the MAC and IP address information here, we copy and paste to here. Okay. Let's keep going. Capture forward. So PDU moves to hub. Hub is only layer 1 information here. So no IP and MAC address display here. Under the OSI model, we go to outbound PDU. We find the MAC address and the IP address information from here. Then we copy, paste to the spreadsheet. Okay, so here hub, no. That is under the OSI model, no IP, no MAC. But we find the MAC and IP information from the outbound PDU detail we find. So I still put here because that's good for our information analysis later. Okay, so keep going. So hub spread out the information to all these 2 ports. And the switch is not the correct device. So switch reject the information from hub. The 31.2 is a correct device, receive it. So let's click this PDU of the destination. All the MAC and IP address information are here. So we copy paste to here. All right. Let's analyze the information. Do the same thing. On the destination device, destination MAC, source MAC switched, source IP, destination IP switched. These switched addresses are for the opposite journal of echo reply. Okay, and the source MAC and the source IP belong to the same source device. Destination MAC, destination IP belong to the same destination device. All right, and from source to destination, just one hop. Okay, let's do the second ping. Let's go back to real time. This time is ping from 31.5 to 31.4. So ping 172.16.31.4. Okay, ping is successful. And let's switch to the simulation mode. Pin again, I use up arrow, enter, generate PDU. Okay, click here and copy this information, MAC address, IP address to this spreadsheet. Yeah, we can quickly finish here and keep going. Click capture forward. The PDU moves to switch 1, and here switch 1 works on layer 2, so only MAC address information display here, right? And where we find IP address from outbound PDU details. Okay, we copy and put it here. And yeah, because no IP address, that's because under the OSI, no IP address, but we find IP address from the outbound PDU details. All right, then keep going, switch forward, or capture forward, and the switch, the PDU moves to the destination, 31.4. From here, we see the difference between hub and switch. Hub only works on layer 1. So hub only pass message. Hub don't determine which port is connected to the correct device and which port is not. Okay, so let the correct device receive the message and the incorrect device to reject message. But switch is different. That's because switch works on layer 2, and also switch has ARP table. ARP is ARP, address resolution protocol. ARP table to help it to mapping IP address to MAC address. So switch knows where the source MAC is, where the destination MAC is. So switch only forwards the message to the port that is connected to the correct device. So switch will not spread out the message to all other ports, and as a hub does. So no incorrect device will reject the message from switch. So that is a difference between hub and switch. Let's click here, destination PDU. So all the information are here. So we copy paste. Okay, so they do the same, analyze. So on the destination device, the destination MAC, source MAC switched, source IP, destination IP switched, the switched addresses for the opposite journal of echo reply, and the source MAC, source IP belong to the same source device, destination MAC, destination IP belong to the same destination device. That's good. And from the source to the destination, only one hop. Remember that. Okay, we finished part 1. Part 2, gather PDU information for remote network communication. Okay, in order to communicate with the remote network, a gateway device is necessary. Gateway device here refers to the router. Router is the gateway device or the default gateway device. Study the process that take place to communicate with devices on the remote network. Pay close attention to the MAC addresses used. Pay close attention to the MAC address. Why? Because what happened to the MAC address is used. We know that in the local network communication, from the source device to the destination device, there's only one hop. But for the remote network communication, from source device to the destination device is not one hop. It becomes two hops. That's because the router default gateway device involved. Default gateway, this router creates a new hop in the middle between these two different networks. So the first hop is from source device to the router. The second hop is from router to the destination device. So there are two hops from source device to the destination device. So the message come out from the source and move to the router. The source device, source MAC and source IP still belong to the source device, but the destination MAC becomes changed to the default gateway MAC address. This local default gateway MAC address. This is a destination MAC. This is for the first hop. The after router receives message and process it, router will send out the message through another default gateway to enter another different network where the destination device is on. So for the second hop, this another default gateway MAC address become the source MAC of this second, for the second hop. The destination MAC is the destination device MAC. In the whole process, IP address don't change. The source IP always belong to source device. Destination IP always belong to destination device. Only the MAC address, the destination MAC, source MAC, will be changed to the default gateway MAC address on the router. Okay, let's go to do. Step 1, gather PDU information as a packet travels from 172.16.31.5 is here to 10.10.10.2 is here. Okay, so this is a remote network communication. And let's go to 31.5. This time let's ping pin 10.10.2. It's a remote communication. Takes a little bit longer, but it's still successful. Okay, we switch to the simulation mode. At pin again, I use up arrow enter to generate a PDU on the 31.5 computer. Okay, click here. Through my explanation here, we can answer this question. There's what device has the destination MAC that is shown. Destination MAC should be here on the router default gateway. So the answer is router. All right, so let's compare the information. So source IP, destination IP always belong to the source device, destination device. But MAC address, this is source MAC. Source MAC still the same, belong to the source device, source MAC. C788 source MAC belong to the same source device, but the destination changed. Destination MAC changed to the default gateway MAC address. Okay. 741A, the destination MAC. Let's look at here. Let's hover the cursor to the router. Let's see the IP address. Look at the 172 network. The default gateway is 172.16.31.1. all the way to the right, the MAC address 741A, and compare it with the 741A here, 741A. So this MAC address, destination MAC, is the default gateway MAC address. All right. So we copy this information and put here in the spreadsheet. Okay, device, add device is a source device 31.5, destination MAC, which is the default gateway MAC, source MAC belong to the source device, source IP belong to the source device, destination IP belong to the destination device. All right, so keep going, capture forward. PDU moves to switch 1. Switch 1 only MAC address information display here. They copy paste. Okay, so IP address no, and we go to outbound PDU, copy source IP, destination IP to here. So, all right, here is a no is under the OSI model, but here the IP address information we find from the outbound PDU detail. Let's keep going. Move to the router. Router. Okay, here router is we copy the information to here first. Then the source IP, destination IP is same. The destination MAC, source MAC changed. Because here, the outbound is go here. Router send out information. This is the second hop, start the second hop. So the source MAC will be this default gateway MAC. Let's hover to here, hover cursor to here. The 10 network, look at the 10 network. Default gateway MAC address, 10.10.10.1. Okay, all the way to the right, 2401. 2401, that is the source MAC. Here, source MAC, 2401. Okay, 2401, that's source MAC. Destination MAC should be the destination device MAC. So look at here. 10.10.10.2 is IP address. All the way to the right, 4AB6, that is the destination device MAC address. It is also the destination MAC. So 4AB6. Okay, here's a 4AB6 destination MAC. Good, so keep going. So move to the switch 0. Switch 0, MAC address is here. Switch is works on layer 2, so only MAC address information displayed here. Let's go to outbound PDU to find the IP address. All right, so here, no is under the OSI model. IP address is from outbound PDU. All right, so keep going. So move to the access point. Okay, click here. Only layer 1 is here. So access point only works on layer 1 as hub does. Okay, as hub does. So no MAC and IP address here. So we go to outbound PDU. So from here, we find the IP address. IP address always keep the same. This is access point, always the same. Okay, so no is because under OSI, no IP, but we can find IP from outbound PDU details. About the destination MAC, here's a kind of different because of this access point. Here, we can tell this 2401 is a source MAC and 4AB6 is destination MAC. But here it doesn't show this is the destination address. This is the source address. That's because this information is under the wireless frame. But from inbound PDU, you can tell this is a destination for AB6, source is 2401. Because this information is under the Ethernet 2. That's because inbound is this interface. Okay, inbound is Ethernet cable connected to the access point with the Ethernet frame. But after access point receive this Ethernet frame, access point will use the wireless frame to repackage this Ethernet frame and send out through the wireless signal. So the layer 2 frames changed from Ethernet 2 to wireless. All right, so let's copy, paste. So no. The source MAC, destination MAC is wireless. Okay, keep going. Okay, we see access point spread out and message to these two interface. That's because access point only works on layer 1. Okay, it doesn't check the MAC and IP address information for message, just pass message, receive and pass message. Okay, so let the correct device to receive message, incorrect device to reject message. So let's click here, laptop, destination. From here, OSI model these layers, we find out layer 2 is wireless. Wireless on layer 2. MAC address is repackaged inside. This IP address. So let's copy, paste. Okay. Okay, let's do the analysis for this information. So on the destination device, source IP, destination IP switched. Okay, and this one should be switched as well. The switched addresses are for the opposite journal of echo reply. And we find out that source IP and destination IP are always belong to the same source device and the destination device. But MAC address changed. The change is on the MAC address. The MAC address will be changed to the default gateway MAC address on the router. That's the difference. Just a router creates a new hop. And why the IP address doesn't change, but MAC address changed? That's because the IP address is used to send packets from source device to the destination device, This destination device may be on the same IP network, on the same IP network as the source. It might be on the remote network. So IP address can travel anywhere. IP address can travel anywhere, but the MAC address is different. MAC address is used for the NIC to NIC communication or NIC to NIC communication on the same network. So the MAC address is restricted in the local area network. The farthest place MAC address can travel is the default gateway interface. That is the farthest MAC address can travel. So when a packet wants to travel to a remote network, the destination MAC will be changed on the default gateway. This is for the first hop. The router will forward this information through another default to enter another different network where the destination device is on. And this another default gateway MAC address become the source MAC for the second hop. That is why. Okay, so we finished this part. And the reflection questions. We'll quickly go through these reflection questions. Were there different types of cable media used to connect devices? The answer is yes. There are 4 types of media used. One is copper straight through. This is copper crossover. This is the fiber and the wireless. Okay, here's the answer. Did cables change the handling of the PDU? And the answer is no. We don't see the change. Did hub lose any of the information that it received? Hub? No. Even though hub is not smart, hub just pass message, but the hub will not lose message. Will not lose information. Okay, so here's the answer. What does hub do with MAC addresses and IP addresses? Hub would do nothing with MAC address and IP address because hub just pass message. Did the wireless access point do anything with the information given to it? Here, access point, the information given to it is through this Ethernet cable. What the access point do is access points will use the wireless frame to repackage the Ethernet frame. That is what access point do. Okay. So here's it repackage the Ethernet frame as wireless 802.11 frames. Next, was any MAC or IP address lost during the wireless transfer? Wireless transfer will not lose any information. No. What was the highest OSI layer that the hub and access point used? Only layer 1. They only works on layer 1. Okay. 8. Did hub or access point ever replicate a PDU that was rejected with a red X? Yeah, red X, yes. Both access point and hub ever replicate a PDU that was rejected with a red X. Yes, the answer is yes. You know the reason, I explained already. And when examining the PDU details tab, which MAC address appeared first, the source or the destination? The answer is destination. Okay, that is the destination. Let's go to here, you will see. Here the detail. Okay, PDU detail. Here's the destination address, then source address. So the destination address first. So here the answer is the destination MAC address appeared first. Why would the MAC addresses appear in this order? That's because that's for the very quickly forwarding message. Okay, here that's because a switch can begin forwarding a frame to a known MAC address very quickly if the destination MAC address is listed first. Okay. Next, was there a pattern to the MAC addressing in the simulation? The answer is no. The pattern is to identify different networks. So from the MAC address, we cannot tell this MAC address belongs to which network. We cannot tell. But an IP address we can tell. Like this IP address 172.16.31.5 belong to the 172 network. 10.10.10.2 belong to the 10 network. So that is the pattern. So here the answer is no pattern to MAC addressing. Did switches ever replicate a PDU that was rejected were a red X? No, because switch works on layer 2, and the switch has ARP table to help it to mapping IP address to a MAC address. So switch knows where the source MAC is and where the destination MAC is. Switch only forwards message to the interface or port that is connected to the correct device. So no incorrect device to reject message from switch. So the answer is no. Every time that the PDU was sending between the 10 network and the 172 network, there was a point where the MAC addresses suddenly changed. Where did that occur? That occurred on the router. We know that already. On the router, the MAC address will be changed on the default gateway. On the router, okay. Because MAC address is restricted in local area network. 14th, which device uses MAC addresses that start with 00D0.BA MAC address? 00D0, 00D0.BA. Okay, this address, this is a MAC address, destination MAC. So this is the remote network communication. So the destination MAC should be on the default gateway on the router. The answer is router. The device is router. What device did the other MAC addresses belong to? Here is MAC address totally belong to 3 devices. One is a source device, one is destination device, one is a router. But we mentioned router already, so it asks what are the other MAC address, what device? The other device would be the source device and the destination device. Source device, destination device. Okay, or the sender or receiver device. And so here's the answer. 16th, did the sending and receiving IP addresses change field in any of the field? No. Sending, receiving IP address change field? No. Only IP, only MAC address changed. Okay, IP address no change. When you follow the reply to a ping, sometimes called PON, ping-pong, okay? The PON is also called an echo reply. Do you see the sending and receiving IP address switch? Yes, both IP and MAC address switched. For the opposite journal of PON or echo reply. What is the pattern to the IP address used in this simulation? The pattern is like the 10.10.10, the 172.16.31. That is a pattern. Okay, because the pattern is to identify the different network. Why do different IP networks need to be assigned to different ports of the router? Each port assigned a different IP. That because the function of the router is to interconnect different networks. So each port is required to have the non-overlapping address. Okay, here's the address. Here is the, because the function of the router is to interconnect different IP networks. And each port of a router requires a set of non-overlapping addresses. So we can compare the difference between router, switch, hub, and access point. The difference is hub is the only device that connects a separate network, but the switch hub and access point, they just simply extend the existing local area network to extend the IP address family. That is the difference. 20, the last question. If this simulation was configured with IPv6 instead of IPv4, what would be different? In order to answer this question, we need to go to this OSI model, these 7 layers. Okay, let's go to here. We'll see. All right. The change IPv4 to IPv6, this will happen on layer 3. Because layer 3 is IP address. All other layers will not change. Like layer 1 is ports, physical ports. Here's the physical ports. Physical ports is where the cable is inserted into. That will not change. Layer 2 is the MAC address. MAC address is in the hardware, so will not change. Layer 4 is port number. Here the port number on layer 4 is logical ports. Layer 1 ports is physical ports. The logical ports is like port 80 is for HTTP. Port 23 is for Telnet, something like that. So port number will not change. Layer 5, 6, 7 is a session, presentation, application. These will not change. These 3 layers will not change because these 3 layers about the web browser, compression, JPEG like that. So will not change. Only layer 3 will change from IPv4 to IPv6. So here is the answer. Okay, only change IPv4 to layer 3, change nothing else. All right. So we finished this packet tracer. Identify MAC and IP addresses. Thank you for watching my video. If you like my video, please thumbs up, subscribe my channel, leave comments, and share with your friends. See you next time.